everyone, we're going to find the volume of the solid generated by revolving the region by our lines y equals 2, x equals 2, and x equals 5, and the curve y equals 2 plus square root of x minus 1 about the x-axis. So we're rotating about the x-axis here. This is your x-axis. Now I sketched a graph of this curve. So basically it's a square root function that has shifted up by 2 to the right by 1. So there's the starting point there. And then we're bounded by y equals 2, x equals 2, there's x equals 2, and x equals 5. All right, something like that. So this is our shaded region. Now if I do a cross section here like this, from here and then from here, this would be a shell in Y. Now for this one, if I do the same thing I did before, so I have this line, and this line. This is your shaded region. It's the same as exact same thing. And if I go perpendicular to my x-axis, I'm going to have this part right here, and then this in here is 2. This would be a washer in x. All right. So basically, if I use the washer method, which is what we're going to use, our outer radius is your big R of x, and that's going to equal the upper boundary of the shaded region. And that is going to be 2 plus square root of x minus 1. And your smaller r, which is r of x, is going to equal 2. All right. And then using this formula, we have for the volume for the washer method, and we also are going from 2 to 5. We're going to use the volume of the washer method, and that's going to equal pi. And then we're going from 2 to 5. And you take your big R, and that was 2 plus square root of x minus 1 squared minus 2 squared, and then dx. I'll put brackets here. All right, so basically this is going to give you equals pi times the integral from 2 to 5. When I expand this, I'm going to get 4 plus 4 square root of x minus 1 plus, when you square that, that's going to be x minus 1. And then we have this is minus 4 dx. All right, let's see what happens. These 4's cancel. So basically we're going to have this equals pi times the integral from 2 to 5 of x minus 1 plus 4 times square root of x minus 1 dx. All right, so now I can integrate this, and when I integrate it, I'm going to get the volume equals pi. Then we're going to have x squared divided by 2 minus x plus 4 times, and then you're going to have 2 divided by 3, because this is square root of x minus 1. So that's going to be x minus 1. You know you can write this as x minus 1 to the power of 1/2, so it's going to be 3/2. All right, and then we're evaluating this from 2 to 5. All right, so let's see what we get. This is going to equal pi. Now let's use our 5. When you substitute 5, you're going to get 25 divided by 2 minus 5 plus 8 thirds times 4 to the power of 3 halves minus 2 minus 2 plus 8 thirds. All right, this equals 0. This is the same as 4 to the power of 1 half times 3. So 4 to the 1 half power is 2 cubed. So that's going to be 8. So let's finish this up. This is going to give me equals pi times 25 divided by 2 minus 5 plus 64 divided by 3 minus 8 thirds. All right, and this will give me pi and 25 divided by 2, let's see, minus 5 plus 56, doing this one, divided by 3 equals pi, and the common denominator is 6, so that's going to give you 75 minus 30 plus 112. So all of this equals the volume, which is going to be 157 divided by 6 pi cubic units. Thank you. Have a nice day. Bye-bye.